Buried deep beneath the cold grey waters of the North Sea lies a secret. It is a scar on our planet's skin, hidden for millions of years. This secret is called the Silver Pit Crater. Scientists have just confirmed that it was made by a huge asteroid. This asteroid smashed into the Earth over 43 million years ago. The discovery is incredibly important. It helps us understand the violent history of our world. It also reminds us that our planet is part of a much bigger, more dynamic cosmos. Events that happened long ago can still teach us valuable lessons today. This finding opens a new chapter in the story of Britain's deep past. The Silver Pit Crater is located far from sight. It sits about 80 miles or 128 kilometers off the coast of East Yorkshire. You could sail right over it and never know it was there. That is because it is buried under 700 meters of younger rock and sediment on the seabed. The crater itself is huge, measuring about 2 miles wide. It was first discovered by accident in 2002. Scientists from the oil and gas industry were using a special technology called seismic imaging. This technology works like an ultrasound for the Earth. It sends sound waves deep into the ground and listens for the echoes. They were looking for oil, but instead they found a strange circular shape with a peak in the middle. The discovery of this unusual feature sparked a lot of excitement. The shape looked exactly like an impact crater. Craters like this are common on the Moon, but they are very rare on Earth. Our planet's active geology, with its moving tectonic plates, volcanoes and erosion, tends to erase them over time. Finding one preserved so well, especially under the sea, was an amazing surprise. Scientists immediately wanted to know more. Was this really the site of an ancient cosmic collision? Answering that question would take them on a journey that lasted for more than 2 decades, a true scientific detective story. Finding craters under the ocean is particularly difficult. We have mapped the surface of Mars better than we have mapped our own ocean floors. The North Sea has been explored for resources for decades, which is why this feature was found at all. The crater was named after the Silver Pit, a nearby fishing ground. It became the first known impact crater in or around the United Kingdom. Its discovery was a reminder that Earth's history is not just shaped by slow, gradual processes. Sometimes it is shaped by sudden, catastrophic events from space, the evidence of which lies waiting to be uncovered in the most unexpected places. When the crater was first found, not everyone agreed it was caused by an asteroid. The scientific community was divided. A long and fascinating debate began. On one side, some scientists were convinced it was an impact crater. They pointed to its shape. It had concentric rings and a central peak. These are classic features of a crater formed when a large object from space hits a planet at incredible speed. They argued that it was a textbook example. The size and structure matched other known impact sites around the world, making a strong case for a cosmic origin. However, other experts proposed different explanations. They suggested that the crater could have formed through geological processes happening deep within the Earth. One popular alternative theory was that it was caused by salt tectonics. The North Sea basin has thick layers of salt buried beneath the seabed. This salt can move and flow over millions of years like very slow-moving treacle. Some geologists argued that the movement of this salt could have caused the layers of rock above to collapse, creating the circular depression. This process, known as a salt diapir, can create features that look a bit like craters. Another idea was that the feature was a collapsed pockmark. This could have happened if gas, like methane or fluids, escaped from below the seabed. This might have caused the ground to become unstable and slump inwards, forming a crater-like shape. Some even suggested a connection to volcanic activity. The debate became quite intense. In 2009, the Geological Society of London held a formal debate on the origin of the Silver Pit crater. At the end of the discussion, they held a vote. The result was surprising. About 80% of the geologists present voted against the impact theory. For many years, the mystery remained unsolved. The problem was the lack of direct physical evidence. The seismic images showed the shape of the crater, but they could not tell us what the rock itself was made of. To prove it was an impact, scientists needed to get their hands on a piece of the crater. They needed to find something that could only be created by the extreme force of an asteroid strike. Without this smoking gun, the crater's origin story was stuck in a deadlock, with compelling arguments on both sides but no final conclusive answer. The deadlock was finally broken in September 2025. A new study led by Dr. Uisdian Nicholson from Heriot-Watt University provided the conclusive proof everyone had been waiting for. This new research ended the 2-decade-long debate. The team managed to get access to rock samples that had been drilled from the area years ago during oil exploration. These samples, called rock cuttings, were small fragments of rock brought up from deep boreholes. For years, they had been stored away, holding the key to the silver pit mystery within their tiny grains. It was time to look at them very, very closely. The scientists used powerful microscopes to analyze these rock fragments. They were searching for a special type of mineral called shocked quartz. When an asteroid hits the Earth, it doesn't just dig a hole. The impact releases an unimaginable amount of energy and creates extreme pressures and temperatures. This shockwave is so powerful that it can change the very structure of minerals in the ground. Quartz, a very common mineral, develops unique microscopic lines and patterns when it is subjected to this kind of intense shock. These patterns can only be formed by a hypervelocity impact. No other known geological process on Earth, like volcanism or salt movement, is powerful enough to create them. After a careful search, the team found it. Within the rock cuttings taken from the crater's central peak, they discovered grains of shocked quartz. This was the smoking gun. The presence of this mineral proved beyond doubt that the Silver Pit crater was formed by an asteroid impact. The debate was over. The team used a combination of cutting-edge tools to build their case. They used advanced new seismic imaging techniques to create a more detailed three-dimensional map of the crater and the damage zone around it. They also used computer models to simulate the impact and show how it would have formed the features they were seeing. The research published in the journal Nature Communications laid out all the evidence clearly. The asteroid that hit the North Sea was about 535 feet or 160 meters wide. To put that in perspective, it was about the size of York Minster. When it slammed into the shallow sea that covered the area 43 million years ago, it created a crater nearly 2 miles wide. The impact was so violent that it created a surrounding damage zone that stretched for 12 miles across the seabed. This discovery was a triumph for the scientific method, showing how a persistent search for evidence can solve even the most challenging mysteries. The confirmation of the Silver Pit impact does more than just solve an old puzzle. It tells us a dramatic story about our planet's past and gives us a serious warning for the future. The impact of the 160-meter-wide asteroid was catastrophic. As it hit the sea, it would have generated a colossal tsunami. Scientists have calculated that the waves from this event could have reached up to 328 feet or 100 meters high. A wall of water of this size would have devastated the ancient coastlines of what are now Britain and Europe, washing miles inland and completely changing the landscape. It is a terrifying reminder of the power of nature. Discoveries like this are vital for understanding the history of life on Earth. We know that a much larger asteroid impact, 66 million years ago, led to the extinction of the dinosaurs. While the Silver Pit event was much smaller, it shows that significant impacts have been a regular feature of our planet's history. Each new crater we find adds another piece to the puzzle. It helps us build a timeline of these events and understand how they have influenced geology, climate, and the evolution of life. Silver Pit is one of only about 33 confirmed craters found under the world's oceans, making it a very special and important site for study. This knowledge is not just about the past, it is crucial for protecting our future. By studying ancient impacts, we can better predict the effects of a future collision. We can model what would happen if an asteroid of a similar size were to hit an ocean or a populated area today. This helps governments and space agencies develop strategies to mitigate the risk. It informs projects that are designed to track near-Earth objects and, one day, potentially deflect any that pose a threat. The Silver Pit crater serves as a real-world case study for understanding these hazards. Ultimately, the story of the Silver Pit crater is a story of discovery, debate, and perseverance. It reminds us that our planet is a target in a cosmic shooting gallery. While the chances of a major impact in our lifetime are small, the consequences would be enormous. The work of scientists who uncover these hidden scars from the past is essential. It helps us appreciate the long and often violent history of our homeworld. More importantly, it provides the knowledge we need to prepare for the future and protect ourselves from the ever-present dangers from space.